it, leave it, stop, format it, touch it, bring it, stay it, watch it, turn it, leave it, stop, format it, touch it, bring it, stay it, watch it, turn it, leave it, stop, format it, touch it, bring it, stay it, watch it, turn it, leave it, stop, format it.
Let's go. Welcome back, class. All right, in this installment, we're looking at future values of investments. And our learning target is, wait for it. Our learning target is, I can determine the future value of a periodic deposit. And what I mean by that is, we're talking about determining the value of something when you're going to be making ongoing investments month after month. And the thing to know is that in our previous lessons, we were talking about determining a value based on our compounding interest, but we were only making one deposit. Here, we're making multiple deposits over a period of time. So let's consider the first question. We have Rich and Laura. They're 45 years old. They open up an account at Citizens Bank with the hope that they're going to gain enough interest in their retirement age at 65. They deposit $5,000 each year into an account that pays 4.5% interest compounded annually. What is the account balance when Rich and Laura retire? Okay, let's consider what we know. We know that we need the principal. And based on what I see so far, the principal would be $5,000 being deposited every year. We know that we need our rate, and our rate looks to be 4.5%. We know that the number of times that we compound, so we're going to compound annually. So that means that we're going to compound once a year. And that we know that if we start at 45 years and we end at 65 years, that's going to be roughly about 20 years. Okay, so we have our pertinent information, and we can actually make some sense out of this. So here we are. Okay, now I'm going to show you guys a way of kind of simplifying this this formula so that it's not as messy. I have a fraction inside a fraction, and for some people that's super okay. Other people it's kind of hard to look at. So I want you to consider the following. What if we took all the information that was inside that parentheses, figure that value out first, and then store that value under the X variable. So I'm literally saying, I've retyped this information into my calculator, and I'm going to solve for it. I'm going to hit enter, and I see that everything inside the parentheses is equivalent to this decimal right here. I'm going to store this decimal under, here's my store key right here. I'm going to store that under the X value. Okay, well, what am I doing next? I'm going to rewrite this value with the principal, and I'm going to multiply that principal 5,000 times X, and then divide that by the fraction that we have listed. So what does that look like? Okay, so it would look something like this, where I have 5,000 in my numerator. This number is stored under X, so I'm multiplying it by that number. In my denominator, I got 0.045 over 1, which just simplifies to 0.045, and I hit my return key. All right, that's what I'm looking for. I'm looking for $156,857.11. Okay? So that is an alternative way of looking at it. So what I said is I found the value inside the parentheses initially. That would be step one. I store that value under X. And then I rewrite the equation where I have my principal times X divided by my rate and the number of times I'm compounding. Let's take a look at another problem. So in this problem, we're asking how much more would Rich and Laura have in their account if they decided to hold off retirement for one extra year? So instead of retiring at 20 years, like we did in my first question, an extra year would mean I'm retiring at 20 plus 1 or 21 years. So what would that look like? It would look a little bit like this, where I have my principal, the information I have in the parentheses, and I'm dividing that by my rate and how many times I'm compounding it. The value I'm going to get is $168,915.68. Okay, and I would take that second value and subtract it from the value that we got in our first problem and find my difference. In this case, my difference is $12,058.57. Okay, easy peasy. Let's consider the next question. In my next question, it says, how much interest will Rich and Laura have earned in 20 years? Okay, so what am I finding? Well, I got to find the total amount he deposited and the number of years. So my total, so every month I'm taking that $5,000 and I'm investing it into this vehicle, this CD or whatever, and I'm doing it for 20 years. Well, that amount, whatever it is going to be subtracted from the $156,857. So just doing this in my head, 5 times 2 would be 10. So I have a total of 1, 2, 3, 4, 5 zeros. And that would put me, oh yeah, 5 zeros. 1, 2, 3, 4, 5. That put me at $100,000. So if I take $100,000 and subtract that from my $156,000, that means my difference, the couple will earn $56,857.11 in interest. And that was the question, key of the question. They wanted to find out how much interest was earned. Okay, let's consider our next problem. So in this problem, we have Linda and Bob. They've opened up an online savings account at 3.6 annual interest rate compounded monthly. If they deposit $1,200 every month, how much will there be in the account after 10 years? Okay, so what do we know? All right, so we need our principal. Okay, check, found the principal. We need to know what our rate is. Our rate, okay, 3.6%, good. I need to know how many times it's being compounded. Well, it's going to be compounded every month. Yeah, compounded monthly rather. So compounded monthly means what? It means it's going to be compounded 12 times a year. Okay, I need to know the duration, how many years. There's 10. And so now I have all my pertinent information. Okay, so based on the pertinent information in our formula, we're going to set up our equation like this. Okay, now I am recommending, again, step 1, determine what you have in your parentheses first, find that value and then store it under X. So for example, I've already done it in the calculator. I find the value. There it is, 0.43 and change. Store that value under X. Now that I have that value stored under X, I'm going to take 1200 and multiply by that X. Then I'm going to divide it by my numerator is 0.036, denominator is 12. I'm going to find the value by hitting enter. And yes, indeed, I said should have $173,000 and $22.87. Okay, so that is the cost of the amount that should be in the account after the 10 years. Okay, let's consider our next question. So in our next question, it says that you deposit $1,200 every month, and it yields 3.6 interest, and it's being compounded semi-annually. So annually means once, semi-annually means twice. How much will be in the account after 10 years? No, actually, this is very similar to the problem we just had in that the principal is the same, the rate's the same, the number of years is being compounded is the same. The only difference is that this is semi-annually and this is compounded monthly. So this number here, down here and here, will be different, which should reflect 2. So let's consider the shortcut we talked about before. So again, everything in these parentheses, this double parentheses, we're going to find the value of that and then store that under the X value. So got that already plugged into my calculator. Let me find the value of it. Okay. All right, 0.428 and change. I'm going to store that under my X value. All right. So now that value is stored under X, I'm going to take the 1200, multiply it by that X, and divide it by that 0.036 over 2. And I already have it in the calculator. Let me hit return. Okay, wonderful. Let's see here. I love it when I see something that looks different from what I expected. Let me troubleshoot this for a second. Okay, I'm back. So after double checking this 2-3 times, I've determined that the answer is what it is, 28,583. And if I'm going to just kind of compare here, compare contrast, this is compounded monthly, where this is compounded, semi-annually. It does make sense, number sense-wise, that this number ought to be bigger than this number. Okay, I felt good about that. Let's consider our next question. All right, so here's our final question. So real world situation. So recently my son buys a 2016 RAV4 hybrid. And he gets a really decent price, $23,495. And the salesperson, honest guy up to this point, tries to slip in a $2,200 maintenance agreement. Now, this was an add-on. This is not something that we needed. And, my son was ready to kind of get into it. And I said, wait a minute, well, hold on. He's telling you that you got this rust proofing, you get a replacement fob, your alloy wheels if they're damaged, your sunroof, your sensors if they're damaged. What if we just took the money that you were going to use for this maintenance agreement and we thought about it strategically? So we're going to finance this car for 5 years anyway. So let's think about what we know about compounding interest so we can predict the future value if you use this money and work smart and not hard. So working smart, instead of fronting this 2,200, let's just say that every year we deposit at 440 into a CD. that's paying 2.5% interest, and we're getting compounded annually. That's not a lot. That's just once a year. What would the numbers look like? Well, they should look like this. Uh, okay, what should our numbers look like? Okay, so 440 is what we're going to be depositing every month. We said that we're going to do this for 5 years. We said this is what our interest rate was. We're doing this annually. Okay, so in my calculator, what I should have is the following. Okay, so my value inside these parentheses should be, okay, 0.13. We're going to store that value under X, likewise. Okay, now we put this as a expression, 440 times X over 0.25 over 1. We hit return. Okay, that's what I expected. $2,312.78 is the value that we would be looking at if we just put that same $2,200 into a nice CD. And the best part, and this is what I would emphasize, the best part is not only am I making that money up in interest, instead of me fronting $2,200, I'm only starting with 440, but I'm doing that every month. Okay, so this video ran much longer than it normally would run. Um, I wanted to show you, a way of breaking down the work so it's a little bit easier to see. The calculator typically is a struggle for many, but I hope by you watching it, if necessary, rewatching it, you'll get the practice needed so that you become familiar and more importantly comfortable with it. Okay, in the internal words of my mentor, remember 30 minutes of study a day keeps bad grades away. Okay, until we reconnect. Ciao.